So now we want to take a quick look at some different types of areas between two functions that we might run into in this section. So first off, we've got two functions, cosine of x and 1 minus cosine of x, and we want to look at them from the interval 0 to pi. So I drew a graph here from 0 to pi down in Desmos. So we're looking from 0 to pi here. And we have two different areas that we need to look at. We've got this first area here where our cosine function is a function on top and our 1 minus cosine function is a function on the bottom. And then we have this area, much bigger area that I have to shade in here, where we've got our 1 minus cosine of x on the top and our cosine function on the bottom. So one of the things that we're going to need to figure out is what's this point right here where those two functions meet and we change which one's the function that's on top and which one's the function that's on the bottom. So we need to take our two functions, set them equal to each other, and solve for x. So we will do that. Here we get 2 cosine of x is equal to 1, and then divide both sides by 2. So we've got cosine is equal to 1/2. We know we're looking for the solution in between 0 and pi, and this ends up being, if we remember some things about our unit circle. If you don't, like me, it's okay. You can kind of grab your calculator and start doing things like pi over 4, pi over 2, pi over 3. And drawing the graph is also helpful because we can kind of see about where it is. That's not quite pi over 4, which would be kind of right here, and it's not pi over 2. So, you can kind of get the idea, sort of remembering what the big values of pi that you look for with these. So that's where our two functions sort of cross over. And so what we're going to need to find is the two different integrals. We're going to have to find the integral from 0 to pi over 3, where our function cosine of x is the function on the top, and our function 1 minus cosine of x is the function on the bottom, plus we're going to have to do the integral from pi over 3 to pi of 1 minus cosine of x when that's the function on the top, minus our regular cosine of x when that's the function on the bottom. So again, what we found here, what we're doing is this first integral is this first area, and then our second integral is this second area. So what's nice about this is that these two integrals, they're basically pretty much the same. The signs are a little bit different. So here, remember you've got to distribute that negative through. So you're going to get a -1 and a plus cosine. So we're going to get 2 cosine of x plus 1. And then on our other integral, we're going to get 1 minus 2 cosine of x. So they're pretty similar in terms of what we get to take the integral of. So for our first one here, we are going to get 2 sine of x plus x from 0 to pi over 2, or pi over 3, excuse me. And our second one, we're going to get x minus 2 sine of x, and that's pi over 3 to pi. And then now it's just a matter of plugging everything in. I think I'll save us all of that. I'll say we'll write fundamental theorem of calculus. And you have to do it twice, right? You've got to do the first function where you plug in pi over 3, and then minus plugging in 0. And then we have to do the second one where we plug in pi and then subtract plugging in pi over 3. And we will get 2 square root of 3 plus pi over 3. All right, so let's take another look at another kind of function that we could have. Ooh, this is interesting. So we haven't seen things like this before. So find the area enclosed by the functions f of y equals 2y and g of y is equal to y squared minus 3. Oh, and then I don't say on the interval. I left that in there, and I don't think we need that because we're going to find the interval. So it's going to be the area enclosed by those two functions. So this is x equals 2y. We've switched what is our independent variable and our dependent variable. So if you're not sure what these look like, and if you're not, that's okay. It's weird to look at these kinds of equations like this. And here's what they are. Greek Desmos can graph them, which is really nice. It's very, very helpful. And so that x is equal to 2y, that is a linear function. And it is actually the same function as 1/2 x is equal to y. And then our x equals y squared minus 3, that's not a function, but it is, if we wanted to graph that or write that as a function, we'd have a positive square root of x. I think it would be, yeah, it was positive square root of x plus 3 and negative square root of x plus 3 to get the top half and the bottom half. That's why it's nice to write it in terms of y, because it gets that equation, it gets that graph in terms of one function. So when I'm looking at these, we're going to actually do exactly what we do when we have them solved for x. We just like rotated everything 90 degrees. So we're going to be looking at finding this integral and having our bottom function and our top function. So sometimes what I do is literally take my graph or whatever it is I'm looking at and physically turn it 90 degrees so it looks like I'm used to it looking. And this starts here at y equaling -1 and it ends up here at 3. And we can find those values the same way that we have for other examples that we've done. We can take our two equations and set them equal to each other and solve. And we get something that factors, which we usually do. And so we get y is equal to 3 and y is equal to -1. So that's exactly what we're seeing on our graph. There's -1 and there's 3. So those are our limits of integration. And instead of the bottom function minus the top function, we're going to have our left function and our right function. And so the left function is going to be like the bottom function and the right function is going to be like the top function. So our integral is going to be from -1 to 3. And our top function or our right function is our linear function, and then we're going to subtract that leftmost function or our bottom function. And now instead of dx, we're going to have dy because our variable that we're integrating with respect to is y. And once we've set it up, this is just like every other one of these integrals that we will do. We distribute that minus sign, we look for any like terms, and then we go ahead and use our rules of integration, -1 to 3. And then again, I won't bore us with the fundamental theorem of calculus part, fundamental theorem of calculus, ... And we will get 32 thirds.